So the next question is question 20. Start off by showing you that graph there. Has 3 points on it, K, L, and M. A student, and the question is, a student throws a metal sphere which follows the path shown above. If air resistance is negligible, which of the following is a correct relationship between the magnitudes of the accelerations AK, AL, and AM at the 3 points shown? So in order to solve this, we need to think about how acceleration relates to displacement. So if the displacement was that it was thrown up in the air, has a parabolic path, we can assume that that it is a quadratic function. So what that means is to find the velocity at any given time, we would need to take the derivative of that, which would make it a linear function. It would be an x to the power of 1 function. And then in order to find the acceleration at any given time, we would want to take the derivative again to get the acceleration, which would then be another reduced power. So it would be an x to the 0 function, which would be just equal to 1, meaning it will just be a constant. So what that means, well, I won't say what that means yet. First we'll do an example. So let's say we just have negative x squared plus 10. So we take the derivative of this to find the velocity. We get negative 2x. In order to find the acceleration, we take the derivative of this again, and we just get negative 2. So, as you can see, no matter what x value you have, the acceleration is always going to be negative 2. So, so what that tells us is that in terms of our problem here, we have our possible answers. A sub k is equal to A sub L is equal to A sub M. B, A sub k is equal to A sub L, which is greater than A sub M. C, A sub k is equal to A sub M, which is greater than A sub L. D, A sub k is greater than A sub L, which is equal to A sub M. E, A sub k is greater than A sub M, which is greater than A sub L. The answer is A. A sub k is equal to A sub L is equal to A sub M. And that's because the displacement followed a parabolic or quadratic path. So when you take the second derivative of that, it is a x to the power of 0, meaning 1, meaning it's just a constant, so it's not going to change depending on x, or what would be time in this situation, t. Yeah, so but the velocity would change because the velocity is only the first derivative. So the velocity would be changing the whole time. The direction, meaning the direction that the ball is traveling in, would be changing. The position of the ball is changing the whole time. the acceleration is not changing.